Our next speaker is Peter Baton. Peter Baton, he's got quite an extensive experience history. RAAF Academy, pilot training. He was from 82 to 92, flew and instructed as a flight combat instructor on RAAF Mirage and Machi aircraft. We've got all kinds of air bases he's been to: Malaysia, Darwin, Williamstown. And most recently, perhaps being a pilot long enough, he thought he'd try being not a pilot or operating unmanned. So presently, he's a director of CoaX Helicopters Limited, and it's been a delight to get to know him and his company, and he's going to speak to us today. Thank you, Peter.
Thank you very much, Peggy. Thank you to the Shepherd Group for the opportunity to present to you today. What I'm going to do is talk to you about what I believe to be the most innovative and exciting opportunity in Australian aviation that we've seen for many, many years. CoaX Helicopters is taking an airframe and moving it into the 21st century and predominantly looking at the UAS opportunities. This project, however, is very much a work in progress. As you will see as I go through, I'm not going to talk just about the hardware applications of this task, but also about the periphery, the engagement with industry and everything else that's required to actually get this company up and running. So firstly, I just want to cover a little bit of history. Drones, a term much to Peggy's chagrin. UASs, for want of a better description, began their operations back in the 1950s. Primarily used for impact testing, weapon evaluation, general targeting missions. The Jindavic, the GAF Jindavic, an Australian innovation, being at the forefront of those applications. In the rotary sphere, the Gyrodyne QH-50, built back in the 1960s, a drone anti-submarine helicopter with offensive capability, giving naval operations the capacity to expand their defensive sphere, carrying Mark 44 torpedoes. There were some 750 of these aircraft built. Some of them flew in excess of 2,000 missions. Quite an amazing technology back in the 1960s. And of course, as we're all very well aware, the military has dominated UAS. The need has been out there originally with high altitude aircraft that were able to take cinematography with U-2s, SR-71s. The advent of long dwell time became apparent, so the move into satellite technology was the next event. But of course, all of those solutions have restricted outcomes, and there needed to be a better way to do business. One of the key considerations is that UASs in the dull, dangerous and dirty scenario are safer than manned aircraft. They have longer duration. There are some, perhaps, considerations for those, things like a B-52 with air refuelling can operate for 24 hours straight. But if you can imagine the concept of a pilot, navigator, weapon system operator in that type of aircraft having to operate for 24 hours straight and be able to achieve an on-time, on-target application of a weapon system and then recover to a base. Very, very demanding from the manpower point of view. The fatigue issues obviously cause more errors than are acceptable for more normal mission operations, so UAS fall into the category of being able to overcome those problems. Political risk, POW capture, Francis Gary Powers being an example in point of why UASs can help to overcome the issues in this scenario. Airspace regulation, much easier for military than what it is for us in the civilian arena. Military-controlled airspace, the operators there have the capacity to do basically what they want. They can desegregate, they can say manned aircraft operate here, UAS operate here. They can take control of high altitude, take control of low altitude, depending on what they need. We are in a different place. Operational theatres also provide a good working environment to test the application of the integration in unsegregated airspace. However, it doesn't always work. In Afghanistan recently, there was an incident, quite a severe and almost catastrophic one, whereby a UAS and a C-130 Hercules collided. The issue here was, who was at fault? The unmanned aircraft, correctly programmed, correctly flight pathed, doing the mission as programmed, collided with a C-130 Hercules. The first consideration was, how can we prevent this accident from happening? The second one, what was the root cause? The root cause was the hurt pilot took a shortcut, transited out of the corridor that he was allowed to fly through, and impacted with a UAS system. These are the issues that we in the civilian environment have to contend with. If it can't be done safely and satisfactorily with the backing, the expertise, the financial control and the discipline of military, we have a very big job ahead of us to actually be able to do civilian operations of UAS. The easy fallback is to operate at high altitude. 55,000 feet and above, outside of commercial airspace, is a good place for military to work. However, as I'll get onto later, that also provides some real constraints as to where UASs have been going. Funding, of course, for military is often available. Most defence bureaucracies invest heavily. Australia with the Shadow project, $150 million plus gone into that project right now. There's not very many military organisations in the world that aren't already looking at or have not invested already into UAS. The Navy Defence Research project, the ACUS VTOL project, just recently issued to try to gain industry participation to find a VTOL solution to track in a GPS-denied environment to a destination that is designated but not prepared, identify whether it's safe to land on that unprepared field, note whether it's marsh, water, solid ground, slope, stable or unstable, deposit a payload, collect a casevac, return to base. Pretty big ask, but this is where we as a civilian community can also capitalise on. The technology that's involved in that is available right now around the world in various aspects. This project, nearly $100 million being made available to invest into it, and we as an industry will capitalise on that. Major defence industry trusts going down all over the world. Moore's Law, a very interesting thing to consider. The QH-50 once again. The forward area of this, gas turbine engine, some of the aircraft engines that were put on that have the capacity of putting out something like 360 horsepower. The back half of this, however, is all of the telemetry, communication system, avionics, flight control systems required to actually operate that aircraft. This is what we'll be using on our CoaX aircraft. This was our prototype, this is our production model. This manages all our GPS communication, manages our data link, manages our flight controls, manages all the operating systems on the aircraft. The size of this package is 2 centimetres by 1 centimetre. A huge gain in the weight, power and systems overhead that that aircraft would have to employ in today's field. Reliability. Generally pretty good, but are we really there yet? And as a civilian community, I think we have to be more robust than what has to occur in military. Military can afford to lose aircraft. They're in a wartime theatre from time to time. Classic example of the RQ-170 Sentinel being captured and demonstrated for political gain by Iran. The Northrop Grumman MQ-8 Fire Scouts currently grounded due to some issue with their final terminal guidance beaconing system. A recent accident by Shibukan copter. An earlier accident by the Yamaha K-Max, RMAX I should say. All these sorts of things we as a civilian industry have to ensure that we minimise.